Guys, in today's class, we are going to start up a new topic that is called OSI model. I hope my screen is visible to all of you and I am audible to all of you. Let
Yes,
me
you
know.
are.
Okay. And I hope my screen is also visible to all of you. Yes, cool. Okay. So, guys, topic of the day is OSI model. Okay. So, before I start OSI model, first of all, we need to understand what is the introduction of OSI model and why we need any types of model. Definitely, there were some challenges. That's the reason nowadays we are using the OSI model, right? Without challenges, why you need any types of model? There is no need of any types of model, right? So, guys, previously at that time there were some challenges. So that's the reason this model was developed. Clear, guys? Everyone. Now, now see some points about the OSI model. The first point about the OSI model is, guys, OSI stands for Open Systems Interconnection. OSI stands for, guys, Open System Interconnection. Clear? Now, second thing, what we need to understand, this is the model. This is the model. This is set of rules, that is set of rules that explains how computer communicate over a network. It means OSI model is responsible, or you can say OSI model is just like a set of rules that define how actually our computers will communicate over the network. Clear, guys? Understand? The third thing you need to understand, first of all, who developed this OSI model. So please remember, OSI model was developed by ISO. OSI model was developed by ISO. ISO means International Organization for Standardization. International Organization for Standardization. Fine. So basically, OSI model was developed by ISO. So these are the 3 points you need to understand. Fourth point that you need to understand, that is OSI model is known as layered approach model. Why this is called layer approach model? Because in OSI model there is total 7 layers. How many layers, guys? Total 7 layers. Clear? Please remember this one. Each layer has its specific functionality. Specific functionality. Clear? Every layer have specific functionality. Clear, guys? And every layer support each other as well. Every layer will support each layer. Clear? Fifth point that you need to understand, OSI model provide us very very clear understanding understanding how the packet encapsulate or decapsulate, how the packet is encapsulate and decapsulate, and after that how this transmission over the network. So guys, basically these are the 5 points that we need to understand about the OSI model. Fine. So again, I'm telling OSI model stands for Open System Interconnection. The point number two that you need to understand, this is the model, and this model is basically set of rules that explain how computers can communicate over the network. And the point number three that you need to understand, OSI model was developed by ISO. ISO stands for International Organization for Standardization. Clear? And the point number four is OSI model is known as layered approach model. So guys, basically layered approach model means definitely in OSI model, there was some layers. Yes. So total 7 layer in the OSI model. So that's the reason it is called guys layered approach model. Clear? And please remember every layer's responsibility, every layer's function is completely different. And all the layer will support each other. Clear? And the point number five, OSI model provide us very clear understanding how actually our packet is exchanging between sender to receiver and how actually our packet is going to travel over the network. So basically guys, these are the 5 points you need to understand about the OSI model. Is this clear guys? Everyone, yes or no? Clear? Now, Now the thing is, what was the challenges? What was the problem? So basically this model was developed. So guys, please remember the OSI model is very important because it helps different device and technology from different manufacturer to communicate with each other. Previously, there was a problem. The problem was, for example, if you have a laptop or if you have any device, for example, you have a device with the manufacturer Dell. You have a Dell laptop. And for example, if you have a Apple device or for example, Apple computer. So that time the problem was if you want to make communication possible between Dell and Apple, that is not possible. That was not possible. It means at that time, every manufacturer has its own monopoly. Every manufacturer has its own monopoly in the market. Getting my point? So basically, for example, Dell was developing each and everything. For example, it's their devices, protocols, everything according to according to their requirement, and Apple is manufacturing according to their requirement. It means your Apple device can't communicate with Dell and Dell device can't communicate with Apple. So if at that time, if you want to make communication possible between these two vendors, you have to pay lots of things. You have to pay lots of amount. Getting my point? So that was the challenges in the market. Fine. For example, if there is a big company, if there was any big company, it means that company has its own monopoly. Getting my point? So that was the problem. There was, at that time, there was no such standardization. Getting my point? So we need one standard platform where all the manufacturer when develop any devices, develop any protocols, develop any rules, they can follow that process. Getting my point? So that's the reason ISO, International Organization of Standardization, developed, or you can say provide one platform, and after that platform, all the vendors, all the manufacturers are developing their devices, developing their protocols, and during the development, they keep OSI model in their mind, right? So that is OSI model. It's something, a standard process that every manufacturer is following. Getting my point, everyone? And after the OSI model, and when all the manufacturer is following that model, now we are able to make communication possible within all the vendors' device. For example, right now I am using the Dell laptop. Definitely, I can ping the Lenovo, Apple, or any devices, right? Why? Because nowadays we are following every vendors are following the standardization process. Getting my point? So that's the reason nowadays we are able to make communication possible between the different protocols, different vendors. Clear, guys? I hope you guys understand. Clear now? So that was the history of OSI model. That was the history of OSI model. Generally, according to the Google, OSI model was developed around if I'm not wrong, around 1970 or 1980 around. Okay, and that was developed by ISO. Clear na? Understand, everyone? So yes, so when you guys will check on the Google, maybe you guys will get around 1970 or 1980. At that time, OSI model was developed, but it was published, or you can say officially, it was introduced in 1984. So basically, that was the history of OSI model. Now, the most important thing, I told you OSI model is called layered approach model. What is called, guys? Layered approach model. Layered approach model means in OSI model, there was different layers, right? That is the first thing. Second thing, I told you, if you remember, OSI model provide us very clear understanding how actually the packet was encapsulated, and how actually the packet was decapsulated, and how actually the packet will transmit between the senders and receivers, right? If you guys remember our previous class, we discussed the packet flow, right? In packet flow, I already show you the R packet and ICMP packet, right, guys? Everyone, how actually the device was preparing the ICMP packet. There was a ICMP header, right, guys? ICMP header at layer number 3. It hand over to the IP protocol at layer number 3, right? So again ICMP, then IPv4 header here, right now. It hand over to the L2, it hand over to the L1. So basically this is the way how your packet was encapsulating. And when this packet was received at the receiver device was one-to-one decapsulating the packet, right? So guys, that is the process, that is the standardization process. And this is possible because of the OSI model. So that's the reason I called you OSI model is called the layered approach model, because here you guys are able to see layer 3, layer 2, layer 1. So these are the different layers. Every layers had different responsibility. Getting my point, everyone? Yes or no? Clear na? So if anyone asks you what is the exact use of OSI model, now I hope you guys are able to answer the question. Clear, guys? Understand? Now, I told you OSI model is called the layered approach model, right? So definitely there will be a layers, right? So what are the layers in the OSI model? Layer in OSI model. Understand? Start with the application layer, guys. What is, guys? Application layer. Application, after application, guys, there will be a call presentation. presentation layer. After presentation layer, guys, session layer. After session layer, guys, transport. After transport, that is called network layer. That is called network layer. After network, guys, that is called data link layer. And the last one is called physical layer. So guys, basically these are the 7 layers in the OSI model. Understand guys, everyone, yes or no? These are the 7 layer in the OSI model. Clear guys, everyone, yes or no? Understand? Now, here one thing you need to understand, these three layers. As a network engineer, we are generally not working on these 3 layers. As a network engineer, generally we are not working on these layer. That's the reason this layer is called guys software layer. Which layer guys? Software layer. For example, any software developer or developer, they are working on these layer. As a network engineer, we are not working on these layer. Clear guys? Everyone, I hope you guys understand. Understand? Yes. Now, I'm telling you some points about the application layer. Application layer. Guys, the first point that you need to understand about the application layer, this layer is responsible where end users interact with network services. Interact with network services. Understand, that is the first point about the application layer. For example, right now, guys, when you guys are able opening the Zoom application, Webex application, any browser, it means as a end user, we are just accessing these tools, right? But behind your laptop, this is called application layer, and multiple tasks is at the end. You there are multiple tasks performing. Getting my point? And that's the reason it's called guys application layer. Now, the second thing you need to understand, guys, application layer is the layer where end users are directly, you can say, accessible, right? For example, we are using the Google Chrome, right now. So that Google Chrome is directly accessible by user, right now. So you can say this layer is directly accessible by end users. Is this clear, guys? Everyone, yes or no? Understand? Now, after that, the third point you need to understand about the application layer. There are many services. There are many services that are running on this layer, or you can say there are multiple services that support on application layer, that works on application layer. Getting my point, everyone? Now, what are those applications? What are those applications? So guys, basically there are multiple, you can say protocols, or you can say multiple services that is running here on application layer. For example, HTTP. For example, HTTP. For example, HTTPS. I hope you guys know HTTP and HTTPS, right? What is this? HTTP means hypertext transfer protocol. What is the use of HTTP and HTTPS? And by the help of HTTP and HTTPS, we are just taking the access of our browser. Yes or no? Right now, we are taking the access of our browser. If we are using the HTTP, it means that is not secure. But if you are using the HTTPS, in this case, it means that is secure. Clear now? Understand everyone? So this is the protocol you can say that runs on application layer, HTTP and HTTPS. There are a couple of more protocol. For example, Telnet. Yes, this is the feature. You can say this is the feature or this is the services. That services also run at which layer, guys? Application layer. That is called Telnet. Next one is, guys, SSH. Yes, the functionality of Telnet and SSH are same. By the help of Telnet and SSH, what we are doing? We are taking the console of our other devices, right? But Telnet is not secure, SSH is secure. Now, come to the point number 5. What is the next one, guys? Anyone here who can tell me? For example, FTP, File Transfer Protocol. Yes, it also works at which layer, guys? Application layer, FTP. Next one, guys. For example, DNS. What is DNS? It also works at application layer. DHCP. Yes, it also works on application layer. Getting my point? So, guys, basically, these are the services that are running on the application layer. HTTP, HTTPS, Telnet, SSH, FTP, DNS, DHCP. Clear? Understand? Now, what is the use of HTTP and HTTPS? By the help of HTTP and HTTPS, we are opening our browsers. We are accessing our browsers. HTTP is not secure. HTTPS is secure because of the SSL. Now, Telnet and SSH. By the help of Telnet and SSH, we are just taking the console. We are just taking the remote of other devices, right? Telnet is not secure. SSH is secure. Now, guys, FTP, File Transfer Protocol. Next one is DNS. What is the use of DNS? For example, right now, if you want to open Facebook on your computer, what you guys will type? www.facebook.com. But I tell you again, computer never understand facebook.com. They understand the IP address, right? And as a human being, that is not possible. We can learn the IP address for every website. For example, if I'm trying to open the LinkedIn, if I'm trying to open Instagram, so I know the name, that is fine. But this is not possible to learn the IP address for every address. So DNS is used to just solve the domain name into the IP address. Understand like this. DNS is just like a technology that what it is doing. It is just converting your domain name into the IP address. Now the next one is, guys, DHCP. What is DHCP? DHCP is basically used to provide the IP address dynamically. Getting my point? So if anyone asks you, how can we assign the IP address on your PC? The answer is there are two ways by which we can provide the IP address. First one is manually and second one is dynamically. Manually means just open it and put the IP address manually, right? That is called manually. That is called static IP address. And dynamic means, guys, your device will get the IP address dynamically. But again, the question is, where these IP address are stored? The answer is in the DHCP server. Clear na? Where, guys? In DHCP server. So basically, these are the feature, or you can say these are the thing generally we get at where guys, application layer. Understand? Now, again, what we need to focus here, or what we need to understand, some more important point here. For example, if you are using the HTTP, if we are using the HTTP, now again the thing is, how actually we understand, how actually we know this is the HTTP. That is the HTTP. So please remember guys, for every application or for every services which you are using right now, for every services there will be a name. There is a name, and that is called port number. That is called guys port number. So please remember these things. For every application, how you identify any application? We identify any application by the help of port number. Clear? So for HTTP, port number is, please remember, port number is 80. For HTTP, port number is 80. For HTTPS, port number is 443. For telnet, if you are using telnet, for telnet, port number will be guys 23. If you are using the SSH, port number will be 22. If you are using the FTP, file transfer protocol, if you are using FTP, file transfer protocol, what will be the port number? Please remember, FTP will use the 2 port number. FTP will use the 2 port number, 20 and 21. Now guys, DNS. I already told you what is the use of DNS. DNS is used to just convert your name into the IP address. Understand guys, everyone? Clear? Now, DNS use the port number guys 53. And the last one, DHCP. DHCP use 2 port number 67 and 68. Understand? So guys, basically these are the things we need to understand here. These are the things that we need to understand here on application layer. Clear? So the most important thing on application layer, what is the use of application layer? So application layer is responsible for, or you can say application layer provide end user interference. End user interference. Getting my point? Understand guys, everyone, yes or no? Right now, it provide the end user interference, right? So as a end user, you can access the application layer. And on application layer, there are multiple services running. For example, HTTP, HTTPS, Telnet, SSH, FTP, TFTP. So basically, these are the services we are getting on application layer. Now, how we identify these services in the networking? We identify these services in the networking by the help of port number, right? So for every application, there is a specific port number. HTTP 80, HTTPS 443, Telnet 23, SSH 22, FTP 20 and 21. FTP use 2 port number 20 and 21. DNS use the port number 53 and DHCP use the port number 67 and 68. Now, guys, tell me one thing. In yesterday class, we discussed ICMP header, right? So when you ping, ICMP packet generate, right? So at layer number 3, first packet was ICMP header. Am I right? Everyone, yes or no? Right? This will hand over to the layer number 3. At layer number 3, which protocol is there, guys? IP protocol. And that is called packet. Layer number 3 hand over this packet to layer number 2. At layer number 2 protocol is ARPA. Yes or no? That is called frame. And layer number 2 hand over this to 1 and it will convert into the bits. I hope you guys understand. This is the same thing we discussed in yesterday class. Right guys? Everyone tell me yes or no? Right? Now, yes. So what is happening here during the time of encapsulation? Start with the layer 3 hand over to the layer 2 hand over to the layer 1, right now? So if any packet is generating at layer number 3, so layer 3, layer 2, layer 1, like this, from top to bottom. Is this possible? From layer 3, it will go to layer 4, it will go then layer 2, it will go then layer 1, like this. No, that is not possible. That is not possible. Packet will always encapsulate from top to bottom. Getting my point, everyone? Yes or no? Is this clear? Now, for example, if you are pinging, then ICMP packet will generate, and ICMP will be the layer number 3 protocol. So if any packet will generate at layer number 3, there you guys will not able to see layer number 4 data, right? So layer 3, layer 2, and layer 1, like this. But for example, if any packet will generate at layer number 7, in this case, how actually the packet will encapsulate? Layer 7, layer 6, layer 5, layer 4, layer 3, layer 2, layer 1, like this. Agree everyone? Yes or no? Tell me. Right? So for example, if you generate the packet, telnet. So telnet generate at which layer? Layer number 7. It will hand over to the layer 6, then layer 5. And it will again hand over to the layer number 4. And then layer 3, layer 2, and layer 1. Agree everyone? Yes or no? Tell me. Right? Like this, our packet will encapsulate. Now the thing is, when any packet will generate at layer number 7, definitely that packet will go at layer number 4. Agree? Yes or no? Layer number 7 to layer number 4. Everyone, that is the basic thing, right? Whenever any packet will generate at layer number 7, definitely that packet will go at layer number 4. Getting my point? Yes or no? Right? Definitely that packet will go at layer number 3. Definitely that packet will go at layer number 2. Right? When your packet will go at layer number 3, which protocol is there? IP protocol is there. And what IP protocol will do? IP protocol will add here IPv4 header, right? And when this packet will go at layer number 2, which protocol is there? ARPA protocol is there. What ARPA protocol will do, guys? ARPA protocol will add the Ethernet header. Getting my point? And when your packet will go at layer number 1, what will happen? Your packet will convert into the bits. I hope these things you guys understand. Clear, guys? Everyone, tell me. Now, in the same way, when the packet generate at layer number 7, and when this packet will reach on layer number 4, definitely at layer number 4 also something will happen, right now? Because till now we discussed in our previous class only about the layer 3, layer 2, and layer 1. We didn't discuss about the layer number 4. But actually, when your packet will reach at layer number 4, definitely something will happen. So please remember, at layer number 4, I will tell you layer number 4 in some detail way. Layer number 4, there are two types of protocol. One is called TCP and second one is called UDP. Please remember. Understand, at layer number 4, there are two types of protocol. First one is called TCP and second one is called UDP. Clear, guys? Now, for example, whatever the services you guys are using at application layer. For example, if you are using HTTP, if you are using HTTPS, if you are using the DHCP, if you are using the DNS, right? So these are the multiple services that you guys are using at application layer. So when these applications traffic, these applications packet will reach on layer number 4, definitely that application will use any one protocol at layer number 4, either TCP or either UDP. Getting my point? What is TCP? What is UDP? What are the content in TCP? What are the content in UDP? We will discuss these things at layer number 4. But right now, just you need to understand on application layer, what are those services generally we are using. So I already told you 7 services here. Maybe there will be some more, but Try to understand right now only 7. So these are the 7 services I told you at application layer. And when these services packet will reach at layer number 4, definitely either they use the TCP or either they use the UDP. Now, how we understand which services will use the TCP and which services use the UDP? We can't understand, guys. We need to memorize it. Okay. So please remember, if there is a HTTP, then definitely it will use the TCP. If you are using the HTTPS, it use the TCP. If you are using the telnet, if you are using the telnet, it will use the TCP. If you are using the SSH, it will use again TCP. If you are using the FTP, file transfer protocol, it will also use the TCP. If you are using the DNS, it will use both TCP and UDP, both. And what about the DHCP? DHCP use, guys, UDP. Understand? I hope these things clear to all of you. Clear, guys? So basically, guys, this is all about the application layer that we need to understand. Clear? Understand, guys? Now, okay. I Your question is, I don't understand telnet, not secure. Why it use TCP? Because TCP is also not secure. TCP is also not secure. I will explain you later. Okay. But yes, please remember, telnet is not secure. SSH is secure. SSH is secure. Now, if telnet is secure, SSH is not secure. Their relation definitely their relation is not with the TCP. Their relation is not with the TCP. Try to understand why we use the TCP. If anyone asks you at layer number 4 why we are using the TCP, first of all, tell me one thing. Right now, I'm living in, for example, I'm living as your neighbor. As your neighbor. Fine. So, for example, this is my house and this is your house. I am living here and you are living here. You are my neighbor. Tell me one thing. If you are neighbor, it doesn't mean we are the good friend. Getting my point? That is not 100% sure. Getting my point? But what we will do? We will talk with each other. Getting my point? Once we will start talking each other, I know something about you, you know something about me. Getting my point? Then maybe we have some better understanding, and then maybe it is possible we will become the good friend. Getting my point? Everyone, yes or no? In the same way, for example, that is the sender packet, that is the sender device, and that is the receiver device. Before sending anything with each other, or before sharing any information with each other, they want to establish a better, you can say, connection. Getting my point? And how actually the better connection will establish? By the help of TCP. Getting my point? So please do not understand like this. By the help of TCP or UDP, we can say that is secure and that is not secure. No. TCP and UDP is here used for the connection establishment, not for the security reason. I hope this is clear to you. Clear? Yes. Telnet. Telnet must be integrity. See, what whatever the application that is using the TCP, definitely it provide the integrity, because in TCP, I will tell you in a very detailed way when I will teach you that layer number 4. TCP provide you, TCP is the reliable protocol. TCP is called reliable protocol, and the reason is in TCP, whatever the packets you are exchanging, your device is sending, your device will get the acknowledgement for that packet from the receiver end. Getting my point? So that's the reason TCP is called the reliable protocol. And that's the reason you are telling it must provide the integrity. Yes. Clear? Very good. Now, guys, come to the next layer that is called application layer. That is called presentation layer. Now, at presentation layer, we need to understand some point that is about the presentation layer. I told you generally as a network engineer, we are not using these three layers because these three layers is called the software layer. Okay. At presentation, the name is presentation. When you read this line, you will understand half of the thing. Presentation means just present the things. Presentation means just present the thing. For example, right now, if I am start teaching in my local language, maybe maximum guys are not able to understand. Tell me yes or no, right? That why? Because in whatever the things I am telling you, getting my point, you guys are not able to understand because you don't know that language. Getting my point? In the what is the solution then? The solution is we need a standard language in which you guys are comfortable and I am also comfortable. Getting my point? In the same way, in the same way. For example, if any traffic is going in, for example, any different language, there are multiple languages. For example, ASCII, EBCDIC. So generally, there are multiple languages in networking. Getting my point? For example, if your packet will generate at layer number 7, maybe they will be in the different language, different coding schemes. Getting my point? Coding schemes, right now. So in this case, your receiver device will not understand. Getting my point? So in this, so what is the solution? Solution is whenever your packet will reach at layer number 6, that is called presentation layer. At this layer, your packet will convert into the standard format. So complete network can understand your packet. Clear, guys? Everyone? Yes or no? Understand? So the main thing you need to understand about the presentation layer, this layer is responsible for translating data between the format used by the application and the format required for the transmission over the network. So maybe from application layer, you will understand, you will get the data in the different format. For example, you will get the format in the CSCII format, or you will get in the format. There are multiple format. For example, CDIC in this format. But in a network, if you are sending your data, if you are sending your packet with this format, your network will not understand. Your destination device will not understand. Getting my point? So what is the solution? The solution is you need to convert this into the standard format. So presentation layer will convert your application layer data into standard format. So network or destination device will understand this. That is the use of presentation layer. Clear, guys? Everyone, yes or no? One more point you guys can please remember this one. At presentation layer, generally encryption, decryption happen on the presentation layer, right? ENCRYPTION, encryption and decryption will happen on this layer. Understand? Clear? Even one more thing you guys can remember. For example, if you are sending the huge data or big data over the network, so basically the compression of the data also happen on this layer. So data will compress at this layer. So guys, basically these are the 3 points you need to understand about the presentation layer. Is this clear to everyone? Tell me, guys. Now, next thing, guys, next layer is called session layer. What is the use of session layer? What is the use of session layer? So please remember this layer is used to manage the or control the connection between computer. Computer means sender or receiver. Again, I'm telling computer between the computer means, guys, sender and receiver. Getting my point? Computers means sender and receiver. Clear? This layer also ensure that your data is properly organized and synchronized. This layer is also responsible for this. One more thing, at this layer, there is concept of session ID. There is a concept of session ID. That's all. This is the thing you need to understand about the application layer. Sorry, guys, session layer. Is this clear, guys? Everyone, tell me. Anyone here who do not understand? Let me know. Now, one more thing I just want to clear. Here, I told you one concept that is called session ID. What do you mean by session ID? Try to understand session ID means. For example, if you open any browser or Google Chrome, there will be a different tabs. Yes or no? For example, that is tab 1, tab number 2, tab number 3, and tab number 4. For example, here I open the Facebook. Here I open the Instagram. Here I open, for example, Zoom. Here I open LinkedIn. Now tell me one thing. If I ask you a very basic question, for example, if you are right now working in this tab, you are looking this tab. Is this possible? You will get the content of this tab here. I mean, different tab content in different tab. Is this possible? Answer is no. That is not possible. For example, if you are watching the Instagram, That is not possible. There you will get the LinkedIn content, right? That is not possible. Why? Because we have a different tab, right? So for example, if you are in the tab number 2, you will get all the content of Instagram related, not LinkedIn related there. Getting my point? Why we have this type of feature? Because of the session ID. Because of the session ID. For example, if you are working in the tab number 1, and if you are using here facebook.com, so there will be a connection between your computer and Facebook server. What I told you, session layer. Session layer is responsible for establishing or manage the control the connection. Getting my point? So what do you mean by connection here? Connection means between your devices and the server which you are accessing right now. So for example, if you are opening the facebook.com, it means you are searching anything on the Facebook server. So definitely there will be a connection between your computer and Facebook server. And who is managing these things? Session layer. Who is managing these things, guys? Session layer. First thing. Second thing, there is a concept of session ID, and by the help of session ID, every content in different tab will be separated. Getting my point? For example, if this tab is sending the data, there will be a session ID, guys. For example, session ID is 0001. And when this packet will reach on the Facebook server, it will reply with the same session ID 0001. So that's the reason you will get the response in the same tab. In the same tab, not in the different tab. It means in every tab, there will be a session ID. I hope this is clear to all of you, session ID, right now. So at session layer, there is a concept of session ID. Clear, guys? Everyone, yes or no? Understand? Now, transport layer, guys. Transport layer is called which layer, guys? Layer number 4. Transport layer is called layer number 4. Clear? The first point you need to understand about the transport layer is layer is responsible for end-to-end communication. End-to-end communication. What do you mean by end-to-end communication? Same thing I told you. I told you, for example, if you are living in my neighbor, it is not necessary. We are good friend. We are exchanging the things between each other, right? Once we will become the good friend, when we will communicate with each other, and once we will become the good friend, then we can exchange the things with each other. For example, today I cook very special thing. Definitely I will share with you. But after become the good friend, yes or no? Right? In the same way, that is the sender device, that is the receiver device. One is the sender device, one is the receiver device. First of all, both devices establish a proper connection with each other. After that, both devices will exchange the thing with each other. Getting my point? But the thing is how both devices will establish a connection. And that connection, guys, generally established at which layer? Please remember that is called transport layer. So that's the reason I told you transport layer is responsible for end-to-end communication. Getting my point? So that's the reason transport layer is called, guys, end-to-end communication. Clear? Point number 2, guys, at transport layer basically support, there are some functions, that some features at transport layer. The first feature is called segmentation and sequencing. Segmentation and sequencing. I'm not going to explain you guys segmentation and sequencing because in yesterday class I already explained you. For example, if you are trying to send a big data over the network at layer number 4, your data will break into small chunks, right? And that is called segment. For example, that is 100 byte data, and that is the PC number one, and that is the PC number two. That is the link. If PC number one wants to share the 100 bytes data, PC number one never share the complete data in one go. What PC number one will do? PC number one will break this data into small chunk. 25 byte, 25 byte, 25 byte, 25 byte. It means there is how many chunks? The total 4 chunks are there. And that is called segment. That is called segment. Each chunks is called, guys, segment. Please remember. What is each chunks is called segment. Understand? And the process of breaking the big data into small chunks is called segmentation. Is called segmentation. Clear na? Understand? So I hope you guys understand what is the difference between segment and segmentation. Segment means the one part is called segmentation and the process is called segmentation. Clear, guys? Understand? Now, what do you mean by sequencing? In yesterday class, I told you for every segment, there will be a one sequence number. For every segment, there will be a one sequence number. For example, that is the chunk number one, segment number one, sequence number is 001, 002, 003, and 004. Why sequencing is important? Because when PC number one is sending this small segment over the link, that is not guaranteed this PC number two will receive all the packet in the correct order. That is not possible. Maybe PC number two will receive 004 sequence first, then 001, then 003, and then 002. Getting my point? So if PC number two will receive the data in that sequence, then how PC number two will understand? What do you mean? For example, if you are trying to say, how are you? And for example, PC number two receive you first, then how, and then are. So what is the meaning of this one? You, how, are. Is there any meaning? No. This is meaningless. So to solve this problem, we have a concept of sequencing. Fine. So for every segment that PC number two receive from PC number one, PC number two will arrange all the segment in the sequential order by the help of sequence number. By the help of which number, guys? Sequence number. And that process is called sequencing. I hope you guys understand, right? So what do you mean by sequencing, guys? Sequencing is the process by which sender device add the sequence number to every segment, and once these segment will receive to the destination, they will arrange the data in the sequential order by taking reference of sequence number. So guys, that is called sequencing. I hope now you guys understand segmentation and sequencing. Clear, guys? Everyone? Yes or no? Tell me, guys. Is this clear? There is one more feature. There is one more feature at transport layer that is called error detection. Error detection. What do you mean by error detection? Error detection means just find out the error, to check the error. The meaning of this is to find the error in the data at layer number 4. So at layer number 4, if you are sending any data, if you are receiving any data, so transport layer is responsible to check the data, Getting my point? Or you can say that is called error detection. Now, again, the question is how? How actually the error detection works at layer number 4? How error detection works at layer number 4? Okay. Please understand here, guys. That is the PC and that is the PC number 2. When PC number 1 is trying to send any data or any segment, PC number 1 will run one algorithm. PC number 1 will run one algorithm on this data. And after running that algorithm, PC number 1 will calculate one random value. One random value here. Getting my point, everyone? Yes or no? In previous class, I already show you FCS, frame checksum. Yes or no? In the packet, there was a field, frame checksum. Right now, in the same way, PC number 1 will run the algorithm here. And after running the algorithm, PC number 1 will calculate one random value. And PC number 1 will put that random value in the header. In the header with this data. Fine. So PC number 1 send this data to PC number 2. Fine. And inside the data, what are the content? Inside the data, what are the content? Basic thing. Inside this data, there are two things. There will be a payload, or you can say there is the original data, as well as there will be a layer 4 header. And inside the layer 4 header, there will be a FCS value that PC calculate after running the algorithm. This packet reach on PC number 2. PC number 2 check the data. PC number 2 run the same algorithm on this data. And PC number 2 will calculate one value. Now, PC number 2 will match this value with this value. If this value will match, PC number 2 will accept this packet. If this value will not match, PC number 2 will not accept this packet. In this case, PC number 2 will realize the packet I receive here, maybe over the network, this packet is modified. Someone modified this packet. That is not the original packet. If this is the original packet, then FCS values would be same. But why I am getting the different one? Definitely there is some changes in the packet. Getting my point? So by this way, you can say at layer number 4, error detection works. Clear, guys? Everyone? Yes or no? Is this clear? Now, there is a one more feature at layer number 4 that is called flow control. Flow control. Flow control means what? The transport layer basically manages the rate at which data is sent to prevent, guys, basically overwhelming the received device. Overwhelming the receiving device. For example, if at one time I can eat one sweet, then you can provide me only one. Na? If you are providing me 4 or 5 sweets at the same time in my mouth, how can I eat? That is not possible. Getting my point? In the same way, for example, that is the PC number 1 and that is the PC number 2. That is the sender. That is the receiver. So whenever PC number 1 will send any data, PC number 2 will receive that data on this interface. On this interface. Getting my point? Yes or no? For example, PC number 1 sends segment 1, segment 2, segment 3 like this here. PC number 2 receive here 3 segments. Segment 1, segment 2, segment 3. PC number 3 store these three segments where PC number 2 will receive, store these three segments. The answer is on this interface. But again, your question, sir, how? How PC number 2 will store these segment on this interface? That this is the normal interface. Is there any memory on this interface? So PC number 2 is going to store. The answer is yes. On PC number 2, on every PC interface, there is some memory, and that is called interface buffer memory. That is called, guys, interface buffer memory. And generally the device stores some information on the interface in that memory. That is called interface buffer memory. And there is a very limited memory, guys. There is very limited memory. Fine. For example, the capacity of PC number 2 is receive or store hardly 3 segment on this interface buffer memory. And already there is 3 packet is there, 3 segment is there. So PC number 2 is right now processing segment number 3, and segment 1 and segment 2 is stored here. When this segment will process, PC number 2 will check the next one. Like this, it works. But for example, here already there are 3 segments are there. And if PC number 1 is continuously trying to send the segment, what will happen? That scenario is called, guys, overwhelming scenarios. That scenario is called overwhelming scenario. Getting my point? And in this case, there will be a chance to drop your packet. For example, if its memory will full, and if you are continuously sending the packet, definitely your packet will drop here, because PC number 2 interface, there is no such memory to store your packet, and your packet will getting drop. Getting my point, everyone? Yes or no? So to help in prevention, to help in this type of prevention, there is a concept of flow control at layer number 4. At layer number 4. So PC1 and PC number 2 indicating each other. Yes, this is the packet, this is the memory I have, like this. Getting my point? And that concept is called, guys, flow control. So please remember, at transport layer, there is a concept of flow control. Clear, guys? I hope you guys understand very well. Everyone, yes or no? Tell me. That is called flow control. Okay. Now, I told you at transport layer, there are 2 types of protocol. One is called TCP and second one is called UDP. Clear na? The most important thing I'm trying to explain you about the TCP. Please focus here, guys. TCP. First of all, TCP stands for, guys, transmission control protocol. Transmission control protocol. Clear? First point. Who can tell me ICMP use? What is the protocol number ICMP use? In yesterday class, I told you. ICMP use protocol number. Exactly. Excellent. 1. Okay. In the same way, TCP use protocol number 6. Please remember. Protocol number 6. First thing that you need to remember. Second thing that you need to remember about the TCP, TCP is called connection oriented. Oh, sorry. Protocol number 6. TCP is called connection oriented protocol. TCP is called connection oriented protocol. But again, the question is, what do you mean by connection oriented? Connection oriented means TCP perform one task, and the task is called three-way handshake. What is, guys? Three-way handshake. That's the reason we are calling TCP is called connection oriented. Connection oriented means before sending any original data with its destination device, first of all, TCP will establish a proper connection with that device. Getting my point? And that's the reason TCP is called connection oriented. Now, how actually TCP will perform the connection orientation? The answer is TCP perform three-way handshake. Three-way handshake. And by this way, TCP is able to TCP is able to perform connection orientation. Orientation. Clear, guys? Everyone? Yes or no? Understand? For example, try to understand, guys, everyone. That is the PC number 1. That is the PC number 2. Before sending any original packet over this link, first of all, PC1 and PC2 will perform which function, guys? Three-way handshake. What, guys? Three-way handshake. Now, three-way handshake means what? Three-way handshake means both PC1 and PC number 2 will exchange total 3 packets before sending any original data. How many packets, guys? 3 packets. That's the reason its name is three-way handshake. Clear? Now, again, you guys will get the question. Yes, sir, what do you mean by three-way handshake? What are the packets? What are the packets? Getting my point? So see here very carefully. For example, I'm just giving you one example, so maybe it will help you. For example, guys, that is the router number 1. That is the router number 2. And both routers are connected like this. On both router, we are using any routing protocol. For example, we are using BGP. We are using BGP. Fine. BGP, AS number we are using 100. Here we are using BGP 200. Here we are using any IP address 12.1. Here we are using the IP address 12.2. Any IP address. Getting my point, everyone? Now, for example, router number 1 have some data. A router number 2 also have some data. You configure the BGP here on R1 and R2. So you know why we are configuring the routing protocol? After configuring routing protocol, both router 1 and router 2 will become neighbor. Either you are configuring EIGRP, either you are configuring OSPF, or either BGP. After configuring the routing protocol, both device will become the neighbor. And once both device will become the neighbor, then after both device start exchanging the complete data with each other. It means, first of all, R1 and R2 will become neighbor. And after become neighbor, R1 will share this data with R2 and R2 will share this data with R1. Getting my point, everyone? Yes or no? But before become the neighbor, first of all, R1 and R2 will perform, guys, three-way handshake. What is, guys? Three-way handshake. And that is possible because of the TCP. Clear? So in three-way handshake, what will happen? See, R1, first, for example, R1 initiate the three-way handshake. So R1 send one TCP packet. R1 send one TCP packet. Getting my point? Yes or no? R1 send one TCP packet. Guys, in TCP header, there is a concept of flag also. There is a concept of flag. I will tell you later. In TCP packet, when you in IP header, I saw there are three types of flag. I told you. One is MF, DF, and reserved. If you guys remember, right now, in the same way, in TCP header, there are multiple types of flag. Fine. Among these flags, there are two flags that you need to remember. That is called SYN, and second one is called ACK. SYN means synchronization and ACK means acknowledgement. Getting my point? SYN means synchronization and ACK means acknowledgement. So these are the two flags. Fine. So R1 is sending the TCP packet. In this TCP packet, what R1 will do? R1 will enable the SYN flag. R1 will enable the SYN flag. Again, I told you in previous class also. 1 means on or enable. 0 means off or disable. Okay. So SYN value is 1. It means SYN is on. In TCP packet, SYN bit is on. Clear? And at TCP header, in TCP header, there is a concept of port number. There is a concept of port number. I told you at application layer. At application layer, whatever the protocols you guys are using, whatever the services you guys are using, for every services, there is a port number. Right? Why there is a port number? Why there is a port number? Because at when these services will reach at layer number 4, how you will identify which this packet belongs to which services? By the help of port number. Getting my point, everyone? For example, if at layer number 4, I receive any packet with port number 80, then I can easily understand this packet belongs to HTTP. Getting my point? Understand, everyone? Tell me yes or no. Right now? So guys, R1 is sending the TCP packet, and in this TCP packet, SYN bit is on. Fine. And there will be a source port and there will be a destination port. Fine. Fine. Source port will be, guys, any random port. That there will be any random. For example, any random port. For example, 11, 8, 2, 8 something. And the destination port will be, guys, which port? Destination port will be the port number. What is the destination port number? Destination port number will be 179. Why? Because BGP used the port number 179. Getting my point? Yes or no? Understand? So that will be the packet. Router number 1 will send this packet to the router number 2. Router number 2 receive this packet. Now, what router number 2 will do? Router number 2 also send one TCP packet, guys. Router number 2 also send one TCP packet. And in this TCP packet, what router number 2 is telling? Router number 2 will enable SYN bit on. Why? Right now in this packet, router 1 enable the SYN. Now router 2 also enable the SYN. Router 1 is telling SYN means hello. Router 1 is telling hello to R2. Are you getting my point, everyone? Yes or no? For example, understand like this. This is me. This is you. We meet each other. What I will do? I will ask you now, hello, how are you? What you will do me? You will also tell me, hello, I am fine. Yes or no? Everyone, tell me. This is the way we greet each other. Guys, yes or no? Try to relate with me. I'm just telling you a practical thing. Yes, this is the way we greet each other. Right now, in the same way, when this hello reach on R2, what R2 will do? R2 will tell hello. How R2 will tell hello? By SYN. SYN means hello. So R2 is telling hello. R2 will tell what? Acknowledgement. R2 will tell the acknowledgement. Try to understand. R2 will give the acknowledgement of TCP hello. R1 hello. R1 already sent SYN bit on. Getting my point? So R2 will send the acknowledgement bit on. Getting my point? Understand, guys? Everyone, yes or no? Clear? Everyone. So what happened? The meaning of this one is hello. So by the help of this acknowledgement bit, R2 is just giving the acknowledgement of this sin. And by the help of this sin, R2 is trying to send its own hello. Its own hello. Clear, guys? Everyone? Yes or no? Tell me, guys. And for example, this is me. I am telling, hello, how are you? This is you. What you will do? Hello, I am fine. Now, what is this? This is sin. This is, it's your sin, right na? And you are just telling, and here what I am doing, your greetings, I am just giving you your greetings, acknowledgement. In the same way, it send the sin. By the help of acknowledgement, I am just telling you, I am just giving the acknowledgement of your sin. By the help of acknowledgement, I am telling to the router number one, ki, hey, whatever the message you are trying to send me, I receive your message successfully. So by the help of this acknowledgement, R2 is telling to R1 this. Now R2 is sending its own hello to R1. It's on hello to R1. Fine. Now this packet will reach on R1. What R1 will do? R1 again send one TCP packet. In this TCP packet, what R1 will do? R1 will share only acknowledgement bit on. And by the help of this uh, TCP packet, R1 is trying to tell R2, ki, hey, you are sending me one sin and I am giving you the acknowledgement. And by the help of this message, R1 is telling to R2, ki, whatever the message you send me, I receive successfully. So here, how many messages exchange, guys, between R1 and R2? Total 3, right? And by this way, R1 and R2 establish a connection with each other. And that process is called three-way handshake. I hope that is clear to everyone. Clear, guys? Everyone, yes or no? Is this clear? Is this clear? Everyone, tell me. Yes, exactly. So what I discussed, R1, R2. R1 send one packet. R1 send first packet. What packet, guys? TCP packet. Everyone, yes or no? TCP packet. In this TCP packet, SYN bit was on. Yes or no? SYN bit was on, right? Source port was any random port number. For example, 11828 something, right? Destination port number was, guys, 179 because this is the BGP port number. Getting my point, everyone? Yes or no? So that is the first packet R1 is sending to R2. Clear? Now, what R2 will do? What R2 will do? R2 will share another packet. Yes or no? In this packet, what are the content? This packet, what are the content? R2 will send the TCP packet. Getting my point? And in this packet, first one, R2 will send SYN bit on. It's on SYN. Yes or no? Plus, R2 will share the acknowledgement of R1 SYN. R1 SYN because R1 already share one packet and R2 needs to acknowledge this packet. Right now, R2 is trying to say R1, ki, hey, I receive your packet successfully. But how? By the help of acknowledgement. By the help of acknowledgement. Getting my point? So here, acknowledgement will be also 1. Clear? Now, what will be the source port? What will be the source port? Source port will be, guys, 179. Source port will be 179 and destination port will be, guys, and destination port will be this R1 source port number. This one, the port number that R2 receive from R1. That will be the source port in this case. Clear? So source port will, destination port will be, guys, 11828. 11828. Now, this packet will reach on R1. What R1 will do? Again, R1 will send one TCP packet, right? And in this TCP packet, What R1 will do? R1 will share only acknowledgement bit on, because R1 needs to acknowledge R2 SYN packet. So that's the reason R1 is sending the acknowledgement packet, right? And in this packet, source port will be, guys, again the random one, 11828. 11828. And destination port will be, guys, again 179. That's all. The whole process is called, guys, the whole process is called three-way handshake. And this will happen on which layer, guys? Layer number 4. It will happen at layer number 4. I hope this is clear to all of you, everyone. Done? Do you guys understand? Everyone, tell me. Yes. Okay, cool. Now, guys, at the transport layer, there is one more protocol that is called UDP. UDP stands for User Datagram Protocol. User Datagram Protocol. First point you need to understand, it use protocol number 17. It use the protocol number 17. Point number 2, it is fast compared to TCP. It is fast. If you compare with the TCP, it is fast, but it's not reliable. It's not reliable. It means if you are using the UDP, in this case, you will not get any acknowledgement. You will not get any acknowledgement. For example, right now we are communicating over the Zoom. For example, if I am telling you something and for any congestion or any voice issues or something, my voice will drop. Are you guys able to send me any acknowledgement or something? Ki, hey, I do not receive these things. No, that is not possible. That is not happening here. Getting my point? For example, you are talking over the video conferencing. You are using the phone. There we are using, guys, UDP, not TCP. Getting my point? So UDP is definitely fast, but the thing is that is not reliable. That is not reliable. So TCP is able to provide you guarantee your packet is delivered or not. TCP will provide the guarantee, but UDP is not provide the guarantee. It does not provide the guarantee of your data deliver. Understand? UDP is not going to provide you the guarantee of your data deliver. Is this clear, guys? Everyone, yes or no? Understand? Now come to the next topic, guys, that is called TCP header. Again, guys, TCP header. Clear? So for example, you are at layer number 7. You are at layer number 7. Clear? And for example, you are searching anything on the browser. For example, you are using HTTPS. You are doing any HTTPS. So it will hand over to the layer number 6 now. Are yes or no? Everyone tell me yes or no. Right? It will hand over to the layer number 6. Right? At layer number 6. What will happen at the layer number 6? That is called presentation layer, right? So your data will compress, your data will encrypt, your data will convert into the standard format, everything, right? That is not our part. So we are moving to the layer number 5. At layer number 5, your data will move at layer number 5. Are yes or no? Layer number 5 is called which layer? That is called session layer, right? So here session ID will generate. Yes or no? Everyone, yes or no? Right now, session will establish. So everything will happen at the layer number 5. Clear? So come to the layer number 4. At layer number 4, layer number 5 will hand over this packet to layer number, guys, layer number 4. And layer number 4 is called which layer, guys? Transport layer. At which layer, guys? Transport layer. Now tell me one thing. Layer number 4 receive this data from layer number 5. Are yes or no? And this data is called payload. Yes or no? In previous class I told you that is called payload. Fine. After that, what layer number 4 will check? Layer number 4 will check the data that I receive. In this data, what is the protocol? What is the port ID? What is the protocol? We are using the HTTPS. That is called, this payload belongs to, guys, HTTPS. Now tell me, for HTTPS, we are using the layer number 4 will use the TCP or UDP. Who can tell me? Layer number 4 will use the UDP. Sorry, TCP. Layer number 4 will use the TCP. So what transport layer will do, guys? Transport layer add TCP header here. Yes or no? Tell me, guys. Everyone, yes or no? Right now, transport layer will add the TCP header here. Now, we need to understand what are the content inside the TCP header. Getting my point? After adding the TCP header, it will hand over to the, guys, layer number 3. Yes or no? At layer number 3, which protocol is there? IP protocol is there. Yes or no? Everyone, yes or no? Right now, guys, right now. And in previous class, I told you, if you guys remember, at layer number 3, your data is called packet. At layer number 2, your data is called frame. Yes or no? And at layer number 1, that is called bits. So please remember, at layer number 4, your data is called segment. Don't forget. Understand, everyone? So guys, that is called segment. Fine. So what layer number 3 will do, guys? Layer number 3 receive segment, and that is the payload. Right now, that is the payload for layer number 3. Yes or no? Now what layer number 3 will do? Layer number 3 will add here which header? IPv4 header. Yes or no? And the complete data is called packet. Layer number 3 will hand over this, guys, to layer number 2. At layer number 2, which protocol is there? ARPA. Which protocol is there? ARPA. Right? ARPA receive what? Packet. And that is the payload. Yes or no? That is the payload for layer number 2. What ARPA will do? ARPA will add here which header? Ethernet header here. Yes or no? Everyone tell me. And this is complete data is called frame. And next will be, guys, layer 1. Right now at layer number 1, we are using the Ethernet technology. What it will do? It will convert your frame into bits. It will convert your frame into bits and forward by physical medium. Anyone here who do not understand these things? I hope everyone understand the complete information. Yes, this is the way how actually our packet will encapsulate, right? And this is the benefit of OSI model, because at OSI model we have a different layers. Yes or no? At different layers, how actually the data is encapsulating, how the data will decapsulate, we have clear understanding. Yes or no? Everyone, let me know. Done now? So in yesterday class, if you guys remember, I already explained you all the header What are the content inside the header at layer number 3, layer number 2? Agree everyone? Yes or no? Right? These things we already discussed. Okay, now I am going to tell you at layer number 4, I mean in TCP header, content in TCP header. So what are the content in TCP header? Understand? First content, guys, will be the source port number. Source port number. Second will be, guys, destination port number. First will be source port number, destination port number, then sequence number. What is, guys? Sequence number, then acknowledgement number. After sequence and acknowledgement number, there will be a data offset. Yes, data offset. Then reserved. There will be a reserved. Then, guys, flags. There will be a flags. After that, window size. After that, checksum. Then urgent pointer field, options, and data, or you can say payload. That is the content inside the TCP header. Getting my point, everyone? I hope this is clear to all of you. For example, if at application layer, you are using, for example, you are using DHCP. At application layer, you are using DHCP. Now, who can tell me when, for example, at application layer here, at layer number 7, you use the DHCP? It will move layer number 6, layer number 5, it come layer number 4. At layer number 4, there is again two options, TCP or UDP. What it will use, TCP or UDP? For DHCP, I told you. For DHCP, it use the, guys, UDP. Yes, exactly. It use the UDP. So everything will be same, only one change here. Instead of here, add TCP header, it will add here, guys, UDP header. Everyone, is this clear, guys? Everyone, yes or no? Right? Now, what are the content? Content in UDP header. What are the content in UDP header? Who can tell me? Okay, guys, one thing I already told you, TCP and UDP, right? UDP is fast. UDP is fast and TCP is slow. The first, why it is fast and why it is slow, I will explain you later. But the first thing you need to understand, TCP is slow because the size of header of TCP is also big compared to the UDP. Fine. In UDP, there are only 4 content. First one is, guys, source port number, destination port number, then length, and then checksum. That's all. Only there are 4 content in the UDP header. Fine. So that's the reason UDP header size is, you can say, less compared to the TCP. Clear, guys? Everyone, yes or no? Clear? Everyone, is this clear? Now, one thing, what is the difference between TCP and UDP? Difference between TCP and UDP. What is the difference? First thing, TCP is, guys, connection oriented. TCP is connection oriented, but UDP is not. UDP is connection less. I am just only writing the TCP one. Okay, na? You need to understand the just opposite of the UDP. Okay. So TCP is the connection oriented, but UDP is the connection less. TCP is, guys, reliable. TCP is the reliable protocol, but UDP is not reliable protocol. TCP is performing the 3-way handshake. UDP is not performing the 3-way handshake. Getting my point, everyone? Yes or no? Done na? TCP provide the flow control. In TCP, there is a concept of flow control. But in UDP, there is no concept of flow control. In UDP, there is no concept of flow control. TCP header size is 20 byte. What is the size of header, guys? 20 byte. But in case of UDP header size is 8 byte. I told you na, TCP header size is big compared to the UDP. Clear, guys? And the fifth difference, I already told you, TCP is slow and UDP is, guys, fast. UDP is fast. TCP is slow and UDP is fast. Clear, guys? Everyone, I hope this is clear to all of you. Let me know, everyone. Done na, everyone? Yes. Cool. Now, just give me a 1 minute. I explain you what are the content in the TCP header and what is the use. I told you these are the content in the TCP header. Source port, and destination port. What is source port and destination port? So guys, basically the port number just identifies actually the which protocol you are using at the sender end and which protocol you are using at the destination end. That's all. Clear na? In the case, I already explained you now at that time. In this case, you are using the BGP. So that's the reason destination port was 179. Our destination port was 179. So at that, in that case, basically 179 port number ensure that the packet is delivered to the correct application BGP or services on the destination device. Right? And please remember at the source end, there will be a random port number. Fine. Next is, guys, sequence number and acknowledgement number. In yesterday class, I told you at layer number 4, if there are a big size packet, that will be divided into a small chunk that is called segment, right? And for every segment, there will be a sequence number. So that is sequence number. Acknowledgement number. Acknowledgement number is what? For example, if there is a device, if that is the sender device and that is the receiver device, if sender device is sending any packet, sender device is sending any packet, what receiver device will do? Receiver device must need to acknowledge it. Receiver device must need to acknowledge it. Getting my point, everyone? Yes or no? Understand? And that is the use of acknowledgement number. Clear, guys? Everyone? Yes or no? Clear na? It's see here how it works basically. For example, that is the sender device, that is the receiver device. For example, that is the client, that is the server. Fine. It is sending the SYN. It is sending the SYN. For example, sequence number is 1000. It is not sending right now acknowledgement. So acknowledgement will be 0. Packet reach here. What it will do? It will send, guys, SYN plus acknowledgement. Right now, I told you na in the three-way handshake. Yes or no? Everyone, tell me. Clear na? I told you these things. Right? Now, in this case, this receiver device will send its own SYN. Right now, so in this case, sequence number is, for example, 2000. What will be the acknowledgement number? What will be the acknowledgement number? So please remember, acknowledgement number will be just you need to increment 1 with this sequence number. Receiver device receive this sequence number, right? 1000. So it will send the acknowledgement of this sequence number. There will be acknowledgement number 1001. So please remember this one. Clear, guys? Everyone, I hope you guys understand. Clear na? That will be the acknowledgement. And in this case, again, this will send final acknowledgement, right? It will send the final acknowledgement. Then in this case, what is the sequence number? At the first time, this device send the packet with sequence number 1000. So now it will send sequence number 1001. Fine. Now acknowledgement number will be, guys, this device receive the packet here with the sequence number 2000. So this device needs to send the acknowledgement of this SYN, right now. So this device received the SYN with 2000. So acknowledgement will be just one, that is 2001. So basically, this is the way how actually the SYN packet exchange or how SYN and acknowledgement works. I hope this is clear to everyone. Done na everyone. Now, guys, there will be a data offset. That there will be a data offset. So, what is the use of data offset? Basically, data offset specifies the length of TCP header. Length of TCP header. Fine. So, generally in the packet, you guys will see the value 5. You guys will see the value 5. When you convert into the bits, 5 in 5, there will be, guys, how much? 20 bytes is there. I already told you. Now the next is, guys, reserved. Please remember, in reserved field, always you guys will get the value 0. Clear? Now there is a flag. In TCP header, guys, there are multiple number of flag. There are multiple number of flag. There is a flag urgent, URG, urgent flag. There is acknowledgement flag. There is push flag. There is a reset flag. There is a SYN flag. There is a FIN flag. There are multiple flags. I told you about the SYN and acknowledgement. Yes or no? If any device wants to terminate a session, in this case, finish. FIN means finish. Finish flag is used. Clear, guys? Everyone, yes or no? Clear? Now, next one is, guys, Windows. Window is nothing. Window basically specifies the size of receiver device buffer memory. I told you, na, flow control, right? Na, PC1 and PC2. That is the buffer interface. So in window size, you guys will see the size of this buffer memory here. Clear na? That is called window size. Now again, checksum. Checksum. What is the use of checksum? Same use. Checksum is used to just provide the error detection in the TCP header. Getting my point? That is the use of checksum. Now there is the urgent pointer field. Urgent pointer field. So for example, if you want to prioritize any data, right now, if you want to deliver any data very immediately, so in this case, urgent pointer field will use, guys. Clear? And the last one is, guys, one is options. Option. Basically, nowadays, that is not, generally, it is in use. Okay, but generally, it is used in case of MSS. So leave it. Now, next is, guys, data. That is nothing. That is called complete payload. It carries the actual application's data. That is called data payload. Clear? Now, come to the UDP. In UDP, everything is same. In UDP, source port number same. Destination port number is same, right? A length. Length specifies the total length of UDP header and data. Length means total length. Header plus data. Clear? And checksum. Checksum is same use for the integrity purpose. Clear? So I hope now you guys understand each and everything, how actually in OSI model, our complete data, complete packet is encapsulated from layer 7 to layer 1. Understand? So guys, this is all about the OSI model. I hope you guys understand.